Welcome back to the part 2 of Java Serialization and Deserialization tutorial. In this part, we will focus on deserialization process, usage of the transient keyword, InvalidClassException, and the serialVersionUID. In the previous part of this Java Serialization and Deserialization, we learned how to write serialized objects. In this part we will learn the techniques of how to read serialized objects. What is deserialization? Deserialization is the process of reading serialized objects from an object input stream. We will continue from where we left earlier in the part 1, that is, if the ObjectOutputStream file exists already, then we will read the objects from it. Using the try with resources statement, we open the ObjectInputStream file. The FileInputStream opens the file in binary mode for reading bytes of data. It returns an object reference of the existing file to the ObjectInputStream for reading serialized objects. The ObjectInputStream stores the stream reference into the object variable ObjectInput for executing the readObject method. Declare two objects of the continent class. We use a multi-catch block for catching both the IO exception and ClassNotFoundException. The ClassNotFoundException is thrown by the readObject method. It is a checked exception and must be declared either in the signature of the invoking method or inside a catch exception handler. Now read the serialized objects from the stream by using the readObject method. The readObject method will return an object from the stream. In case of a failure, it will throw a ClassNotFoundException. The returned objects must be casted properly before storing into the specified class objects. We will call the readObject method twicely, as we have saved only two objects of the continent class into the ObjectOutputStream. After reading the objects, we will display the data on the screen in a convenient display format. The getContinent method of the continent class will display the name of the continent. The viewCountries method will display the list of the countries according to the continent. Now run the program. Notice that the information contained by the serialized objects in the ObjectInputStream are properly displayed on the console. The value of the area variable is looking a bit odd by having too many zeros after the decimal point. We round it off at 2 decimal points by using the specific format specifier inside the printf method. We add some column headings to the output data for display purpose. The data output is looking good and informative now. Java serialization is a convenient way to deal with the large collection of objects. It eases us by saving our time without any headache. It solves many programming algorithms easily and is highly recommended. Now let us know the usage and purpose of the transient keyword. Instance variables declared as transient will not be saved to the ObjectOutputStream. This is useful, because for security reasons we may not be willing to store our sensitive data in a file. In that case, the JVM ignores the original value of transient variable and saves the default value to the file. That is, transient means not serialized, Java assigns default values only to the object-oriented data types, but not to the primitive types. Java assigns the value 0 to numeric type of class variables by default, false to the booleans, and null is for strings or objects. It is important to note that the local variables will not be assigned any default values and they must be initialized prior to use. The serialized file must be deleted prior to recompiling the program, otherwise an invalid class exception will be generated. Notice that the area of continent variable has returned the default value that is 0. Now let us understand the concept of serialVersionUID. It is a unique identifier and must be declared as static final long. The JVM saves it at the time of serialization with an object. While deserializing the objects, the JVM will search for a match of serialVersionUID. Objects will be deserialized if the serialVersionUID matches, otherwise, deserialization process fails and a runtime exception will occur, known as InvalidClassException. To demonstrate the serialVersionUID, we declare a new variable in one of the classes which implement the serializable interface. Now run the program. Notice that the invalid class exception has caused the program to terminate immediately. It is due to the change we just made by adding a new variable. The solution to this problem is to add a static final long serialVersionUID. By default, the JVM implicitly creates a serialVersionUID, if not explicitly declared. However, it is recommended to declare a serialVersionUID explicitly when doing serialization. Now delete the previously created serialized file and run the program twicely to create a serialized file and display the objects. Notice that, now there is no invalid class exception and the output is displaying the serialized object status successfully. Now modify the source code of the program once again to recheck for invalid class exception. Notice that the program execution is not affected by the partial modification of the source code, that is why the invalid class exception has not occurred. This is the principal advantage of using the serialVersionUID.